Lessons 1 through 10 on the next test. Here's a highlight of Lesson 1. I am not cramming every single thing we did in Lessons 1 through 10 into this review. I'm only hitting the highlights. You are still responsible for everything that we did in Lessons 1 through 10. For example, in Lesson 1, a Ferris wheel is 170 feet high. A passenger car starts at 30 degrees, which would be right here, and then it moves 7/12 of a turn. You should know from the stuff we did with the unit circle before in terms of degrees and then finding the radian value that's equivalent to them, that the circle was marked off in 24 sections. Well, in this case, you're looking at 7/12. Now, in 24 sections, it went like this. There's 15, 30, 45, 60, 75, and then 90 degrees would be here. 7/12 in terms of 24 would be 14/24 of those markings. So we can come over here and fill out the rest of this, where we would have to go a total of 5 different markings there, 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 and there to get to 180. And then start all over again, there, 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 and actually I need one more, so it's going to look a little bit off. Here are your axes, there, and down through to here. And if we need 7/12 of a turn, we could make that 14/24 and go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so if each one is 15 degrees, then I'm going 15, 30, 45, and then 60. And we could draw a triangle there to find the new height. So I'm going to replicate what we just did there down here. That's a 60-degree reference angle. And we know that the height of the Ferris wheel is 170 feet. 170 feet divided by 2 is 85, so that gives us a radius of 85. We are looking for the height here, which is this y value. In order to do that, we would have to use sine, because this is clearly opposite of the 60 degrees, and this is clearly a hypotenuse. So sine of 60 degrees equals y over 85. Cross multiply to get y equals 85 times sine of 60. If you do that in your calculator, sine of 60, and then multiply by 85. And you'll come up with a y value of 73.6 feet. If that's your answer, you're wrong, because the question is asking what is the height in the new position. That 73.6 is not the height in the new position, because the car is right here. The ground is down here. We just found this. But we know that the midway point of the Ferris wheel is 85 feet off of the ground. So we can do 85 minus 73.6 and come up with a value of 11.4 feet. A high point from Lesson 2 is this. A Ferris wheel is 90 feet high. A passenger car starts at 60 degrees and moves 1 1/3 turns clockwise. So if we're going to go clockwise, then we're going in the opposite direction of what a Ferris wheel usually goes. What is the difference in the co-height of the new and the old spot? Alright, we start at 60 degrees, which we will say is here. 60 degrees, and we'll draw a triangle down like this. That's where it starts, and then it's going to make a turn clockwise, 1 1/3 turns. So it's going to start here and go back around this way, and then it's got to go another third of a turn. A third of 360 is 120 degrees. If I go another 120 degrees clockwise from positive 60 degrees, it would take me 60 degrees to go here. And then it would take me another 60 degrees to make that 120. So I would end up out here, stopping in that new spot. And 60 degrees, that would give me a 60-degree reference angle for that one as well. The co-height is this distance from here to here, that x value. We know that the radius is going to be half of the diameter, which is 90, so half of 90 is 45 feet. The x is in the adjacent spot for that top triangle. So I would have to do cosine of 60 degrees equals x over 45. That is the same thing as x equals 45 times the cosine of 60. So cosine 60, and then multiply it by 45, and come up with 22.5. That represents this distance in here. 22.5. That is the co-height from where it starts. But what about where it ends? What's the co-height of where it ends? Is that answer not immediately obvious? It's the same thing. Here is the co-height for this car. Out to here, it's the distance from the y-axis to this point here. It's still going to be 22.5. If you put 22.5 down for your answer, you're wrong, because the question says what is the difference in the co-height of the new and the old spot. Therefore, 22.5 minus 22.5 is 0, which would be the answer. Lesson 3. The sunrise is 6 a.m. The sun is overhead at 12 p.m., which is noon, not midnight. The distance of the sun we will use as being 93 million miles. What is the distance of the sun at 11 a.m.? And actually it says distance, but that should read, what is the height of the sun at 11 a.m.? And remember, this problem was from ancient times when we studied it back then, so they figured that the sun had a certain height instead of just following what we know to be true today. Okay, well, we're going to come in here to this and mark this off as 6 a.m. and this is going to be noon, which is 12 p.m. So we'll start there, then go over to the right. From 6 a.m. to 12 p.m. we have to go 7 a.m., 8, 9, 10, and 11 before we get to 12. That's 5 markings. So we're going to have this, and these two, and then these two out here. That would represent 7, 8, 9, 10, and 11 a.m. The question is, what is the height of the sun at 11 a.m.? So this is where you would draw your triangle down to here. And for your convenience, I am going to recopy that down here so we have something a little neater to look at. That is at 11 a.m. And to go from 6 a.m. to 12 p.m., we have to make 6 movements. 90-degree angle divided by 6 is 15. So if I go 15 at a time for every hour that passes, what degrees will that be for 11? 75. So we'll come down here and fill in 75 degrees in this spot. This is a right angle. The distance of the sun is 93 million miles. We're looking for the height, which is this, and we'll call that h. Clearly that is an opposite side of the 75 degrees. So sine 75 degrees equals opposite h over 93 million. We'll just leave it as 93. cross multiply to get h equals 93 times sine of 75. Alright, so sine of 75 degrees, multiply by 93, and you should come out with a height of approximately 89.8 million miles. Lesson 4. Remember I gave you a triangle and it went in 15-degree increments, and we used part of this for one of our problems we just reviewed, where you mark up the circle in 24 sections. Each section is 15 degrees. You should be able to know how to fill in the radian version doing this. The main thing to remember is the following, that this is not only 0, but it's also any multiple of 2 pi. Depending on how many times you go around. If you can remember that 90 degrees is pi over 2, that 180 is pi, and that 370 is 3 pi over 2, then you should be able to fill in any quadrant in here, because you know every 90 degrees is half pi. So we go a half, then 1, then 1 and a half. Of course, you would have to know that 3 over 2 is 1 and a half. Now, in the first quadrant, we know that since we're breaking this up, the entire circle, into 24 pieces, then 36 divided by 24 is 15. If we do this in terms of 12 for the top half of the circle, because you're going to pi, you have 12 pieces on the top half to get to pi. So if we start at 15 degrees, that's just pi over 12. 30 is 2 pi over 12, which is pi over 6. And 45 is 3 pi over 12, which is pi over 4. You just have to reduce as you go along. 60 is 4 pi over 12, which is pi over 3. And 75 is 5 pi over 12. 90 is 6 pi over 12, which is 1/2, so pi over 2. Any quadrant in here, you should be able to go over by another pi over 12 as you go along. Even if you have to start over here and do 13 pi over 12, because pi is 12 over 12 pi. The next one would be 14 pi over 12, which is 7 pi over 6. The next one is 15 pi over 12, which is 5 pi over 4. And so on. You cannot forget a 30, 60, 90 triangles. In the unit circle, this would be 1. The short leg opposite of the 30 would be half of the hypotenuse. The long leg opposite of the 60 is square root of 3 times the short leg. The 45, 45, 90 triangle, if you have a hypotenuse of 1 in the unit circle, to go from the hypotenuse to the leg, you have to divide by the square root of 2. Of course, we did not leave it as the 1 over the square root of 2. We simplified it. Multiply the top and the bottom by the square root of 2 and come out with square root of 2 over 2. Of course, when you multiply a square root by itself, you just get the number that is under the square root sign. If you wanted to find sine of 60 or negative 60 degrees, remember what quadrant you're in. Starting at 0 degrees, you go back 60, like that. This would be negative 60 degrees, which makes your reference angle 60 degrees. Here's the right angle. This would be a 30-degree angle. And in the unit circle, this would be 1. The short leg would be half of that. And the long leg is square root of 3 times the short leg. So it's square root of 3 over 2, but you're dropping down below the x-axis. So this would be negative. And if you wanted to find sine of negative 60 degrees, you would do sine of 60 degrees equals opposite, which is a negative square root of 3 over 2, over the hypotenuse, which is 1. so negative square root of 3 over 2. If you wanted to do cosine of 135, you should recognize that you end up in the second quadrant out here. 135 degrees is 45 degrees away from 90 and 180, so it's directly in the middle, giving you a reference angle of 45. If this is 1, you would have square root of 2 over 2 there, but this one would be negative square root of 2 over 2 here. And if you wanted cosine of that reference angle, which is 45, you would do adjacent, which is negative square root of 2 over 2, and then over 1, giving you a negative square root of 2 over 2. Lesson 5. A circle with center K is created by x squared plus y squared equals 4, not 1. 4. And you know that we've been over the general form of that, where the radius is found by squaring the term on, or square rooting the term on the right. The square root of 4 is 2. So that gives us a radius of 2. And we have to figure out what the coordinates of point B are. And if we have a reference angle here at 240 of 60 degrees, we want the coordinates of B, which means we could fill in the rest of this triangle since it is a 30, 60, 90 triangle. The hypotenuse is 2. The short leg would be half of that, which is 1, but it is negative since you're in that third quadrant. And for the long leg, you would do square root of 3 times the short leg. It is negative because you're in the third quadrant, going down. So the coordinates of B would be negative 1, negative square root of 3. Lesson 6. X squared plus y squared equals 5 in this case. So the square root of 5 is 2.2. I think it's enough to do 2.2 for this radius, which is AB. So we'll fill that in first. BAD, that angle here, is 45 degrees. Use no decimals. So we have to come up with AB, AD, BD, and AC, and the rest of these down through here. Now, in this case, the directions of use no decimals would not apply because clearly we just had to use a decimal in order to find the hypotenuse. So I'll waive that one for this type of problem. Okay, so if we want to find AB, we just did it. It is 2.2. That is the radius. We want to find AD. AD is an x value. It's adjacent to the 45. So if you do cosine 45 degrees equals x over 2.2, you cross multiply to find it. Cosine 45 times 2.2 gives me 1.6. BD is the opposite side of the 45, so clearly you would have to use sine. Sine 45 degrees equals the opposite, which we'll call y, over 2.2, so do the same thing again. Sine of 45 degrees, and then multiply by 2.2 to get 1.6. In fact, on that one, you may not have even had to have done that to get the answer because it's a 45, 45, 90 triangle. Both legs have to be equal, so they're both 1.6. After that, we would have to find AC. AC is this, all the way out there. Now, it may look funny at the moment, but remember that's the larger triangle. So keep in mind that we know this side of the larger triangle, segment AE, because it is a radius. The radius of this circle is 2.2. So if we use this entire side as 2.2, and we're looking for a hypotenuse. We have an adjacent side to that 45 degrees, 2.2. That's going to be cosine. So we could do cosine 45 degrees equals adjacent 2.2 over hypotenuse, which we don't know. When you cross multiply this, you're going to come up with these two times each other, which means you're going to have an h with the cosine 45. That's a variable. And these two times each other is just 2.2. To get that h away from the cosine 45, you would have to divide by cosine 45. 2.2 divided by the quantity of cosine 45. 3.1. It's simply solving a proportion, which goes back to middle school. CE, this opposite side here, the long one of the 45. Now remember, it's a 45, 45, 90 triangle for the larger one as well. So if AE is 2.2, then CE would also have to be 2.2. Otherwise, you would use tangent to find it. And we've already found AE. It's 2.2. Lesson 7. X squared plus y squared equals 2. Okay, so in this case, clearly, since it's 2 and we find the square root of 2 to be 1.4, then we could use no decimals on this, or we could do the following. We could just say the radius is square root of 2. So I think I might stick with this one and just use radicals on this and show you how to do it. And we could have used radicals on the other one as well. I think we'll use radicals on this. So the square root of 2 gives us the radius, and we have to find secant CAE. Well, if this is 60 degrees, and we have to find secant, which is hypotenuse over adjacent, then we could easily do that only after we have found what these other pieces are. This is 30 degrees, and half of square root of 2 would be square root of 2 over 2. And then for the long leg, it would be square root of 3 times the short leg, which is square root of 6 over 2. So hypotenuse over adjacent would be square root of 2 over square root of 2 over 2, which is the same thing as square root of 2 over 1 times 2 over the square root of 2. And these cancel out just to give you a 2. However, if you did this in terms of decimals, square root of 2 comes out to be 1.4. So how about we put 1.4 here and do the same thing we just did. What's half of 1.4 for the short leg? 0.7. And if I have to do hypotenuse over adjacent, I would get 1.4 over 0.7, which turns out to be 2. So decimals or radicals on that, you're still going to get the same answer. So I think I'll still stick with my original judgment. We'll wipe out the use no decimals thing for that piece like that. It does not apply to all of them. And I'll remind you tomorrow or the next day that you're here which ones that it does apply to as you're taking the test. Lesson 8. Using cosine theta in the interval negative 180 to 360, at what degrees are the following? And you would have to draw your own cosine graph, and I'm giving you graph paper to do that, so you must remember the important points of the sine in the cosine graph. If you do, it will be easy. If you do remember them, you can quickly sketch this here at the bottom, cosine x. And remember that it says to go from negative 180 to 360, so on my graph I would have to extend this out back to here to negative 180 and chop it off here at this point. My maximums are at 0 and 360. My minimums are at negative 180 and positive 180. And then my x-intercepts are at negative 90, 90, 270, and I think that's it. Lesson 9. Convert from degrees to radians. Multiply by pi over 180. And once you do that, you're back to middle school, even before. Let's see, 20 goes into 180 9 times and into this 10 times. So you have 10 pi over 9. And you would do the same thing for this one down here. Multiply by pi over 180. To go from radians to degrees, you multiply by 180 over pi. 4 into itself once, into 180 45 times. The pi's cancel out. And 7 times 45 is going to give me 315 degrees. In lesson 10 we just did that, and we reviewed the homework for it today, and we had a few questions in there about that and we answered them, so there's no need to go over lesson 10 right now.